our daily lives in some way. Okay, now, what was the invention that happened? Now, as we go along, with the transistor 1949 came about the microcontroller, okay, and the computer. The early computers were very, very big. They were probably the size of a room, if not bigger. They consumed kilowatts of power, and they were made up of vacuum tubes and diodes and triodes and whatnot. So they were so expensive, they were so big that they could not be used. But as we progressed, after the invention of the transistor, things became smaller. The computer became smaller, it became more powerful. So we have one, in the earlier days, we had one computer controlling one machine. Okay, this is about 1960s. 1970s, the computer becomes more powerful and we have one computer controlling many machines. Then we proceed further. The computer becomes so powerful that the computer can control all other aspects of manufacturing. For example, material handling, storage, and this is what we call computer integrated manufacturing, which basically means that the computer has become smaller and more powerful. Okay. Today we know that the computer sitting inside your mobile phone is so powerful that it is probably better than the mainframe computers which were there in 1960s. Okay, so that is the way it has progressed. But what resulted in this progress? That is something I'm trying to point out. So the second thing, okay, before we go further, we talked about a robot. What is the definition of a robot? Now nobody seems to agree. That's interesting. Why? Because all the companies want to call their device into robots. In terms of students, if you ask a student what you're studying or what you're making, he'll say, I'm making a robot. Why? It sounds nice. Okay. So people want to use the word robot freely for making good impact, right from industries to students to academics to everywhere. Okay. So that's why nobody seems to agree on what is a robot actually. But it's generally agreed that to be called a robot, a device must do some or all of these three things. So the first is it should move around. So if a mobile robot moves around, then we can say, okay, this thing moves around, it's a robot. In that definition, a vacuum cleaner, today, you get vacuum cleaners which can clean by themselves. Now that is a robot. Eurocap sells vacuum cleaners which can clean your room by themselves. Now that is the definition of a robot. That is a robot. So that's the first point. Second point is it should sense and manipulate the environment. It should have some kind of sensor input output. We saw the mobile robot that it can sense if there is an obstacle in front and take corrective action. So it can sense the environment, it can manipulate the environment. So this is the second thing it should be able to do. And the third thing it should be able is it should display some kind of intelligent behavior. Okay. So if a machine can do either of these three or all of these three, you can call it a robot. That's what people agree today, that to be called a robot, a toy or a machine should be able to do some or all of this. Okay. Move around, very easy to understand, should move around. Sense and manipulate the environment, also easy to understand. If there's an obstacle in front, it should avoid it. Okay, it has an ultrasonic sensor, it can see. What about the third one? Display intelligent behavior. Now this sounds easy, but it's not, because what is intelligent behavior? If somebody were to ask you, are you intelligent? Okay, how would you answer? Okay, so some of these things are very easy to say, but difficult to gauge. What is this intelligent behavior? Okay, so is a student intelligent? Is a teacher intelligent? How do you know? Okay, so now we are asking, is a machine intelligent? Okay, we are not sure if a human is intelligent, we are asking if a machine is intelligent. Now, what is this intelligent behavior? Now, it is generally understood that intelligence is essentially the ability to deal with unknown, unforeseen kind of situations or data. Okay. To give a bad example, well, maybe an example, is if a teacher teaches everything in class and then in the exam he asks exactly the same thing, is it checking intelligence? Probably not. It is just checking how much you can mug up and keep up in your brain. That's all it's checking. It's not checking if you're intelligent. Okay. But if the teacher teaches something and gives a question which is not directly related, but the student has to think and infer from what has been taught, that is probably checking intelligence. Okay. Another bad example, if I say x plus y in terms of a computer program or algebra is equal to z, and if I say x is equal to 2 and y is equal to 2 and z is equal to 4. Okay, so I write a computer program in which x plus y is equal to z. Then I give x is equal to 2 and I give y is equal to 2 and the computer computes z is equal to 4. Is it intelligent? Okay. No, it's not. But suppose I write the program x plus y is equal to z and I say x is equal to 2 I don't say what is Y. Now I say what is Z. Can you tell me? Now you'll have to think. Okay, that if Y is equal to 1, then the answer is 3. If Y is equal to 2, answer is 4. So there is a bound coming now. Okay, now that will require some kind of intelligence. Okay, so this intelligence basically means the ability to deal with information that is not that will require some kind of thinking. Okay, this is again talking in English. What does it mean mathematically? Anyway, that's not a part of this lecture, but it's something to do with AI. Maybe it can be discussed somewhere else. But this is very important, that if a machine can do any of these three, we can say it is intelligent. It is a robot. Now, based on this, we have had 3 generations of robots. We had the first generation, which has very simple pick place. We have second generation of robots, which have external sensors, and third generation, which are intelligent in some way. Now, the second major revolution that came about 1970 is electronics became faster, smaller, and cheaper. The computer, which was so big and expensive, suddenly became cheaper, smaller. And it has become so cheap today that it can sit inside your mobile phone. Now, why did this happen, or what was the invention which caused this? The invention was essentially, in electronics, it was VLSI. VLSI is very large scale integrated circuits. Okay, so because of which you could make the diode triode into small electronic devices as transistors, chips, and put them in a motherboard. So if you look at your mobile phone, you look at your computer, your laptop, it is essentially a board in which there are small chips, and that is about it. Okay. And what enabled that is VLSI. And once we had VLSI, electronics became smaller, faster, and cheaper. Okay. And our lives changed drastically. Okay. The camera that is there in the mobile phone, okay, is so small and is so cheap and is so fast that it was not there maybe 20 years or 30 years ago. And you can see it is going faster and faster. Similarly, processors, displays, and essential technology is VLSI. Okay, so robotics started off with the invention of the transistor. Then we had electronics becoming smaller, faster, cheaper, 1970s. And from 1970s, we had different subjects like vision, computer vision. We had speech recognition. We have artificial intelligence. We have advanced controllers, microcontrollers, DSPs, FPGA, which are used in mobile phones today. Okay, so essentially it came from here. Now, the third great invention that came about was new materials. Okay, smart materials, smart actuators, smart sensors. Okay, this is the third invention that came about, we call the third generation. So this is essentially to give you the history of where it came from, where it is going. Now, robots can be of different types. They can be parallel robots, they can be mobile robots, okay, then stationary robots. Now, these are everywhere. You see them in TVs. Okay, news will have something about a drone. Okay, some weapon which was used by a drone, mobile robots which are delivering something, pizza which is being delivered by a drone today. Okay, so this is a part of our lives. Now, industrial robots, social robots. These are some ways by which robots are classified. What is the future? Now, the future is so many. Robotic drugs to cure disease. Now we are at the stage where we can make robots which are very small. How small? They are so small that they can go inside the blood vessel and do particular tasks. For example, if you want to kill cancer cells, okay, you can. It is already there in so many countries. Okay, where you can go and it's something like a cap. They'll put a cap on your head, and it will cut in a particular shape. And it's very cheap because there is no human intervention there. Other areas like let's move on. This is for rehabilitation robotics. For people who cannot have reduced muscular power or suffer from paralysis or are paralytic, okay, or are disabled. So robots can be used to enhance their walking or their carrying ability. So such robots are already there. These are called exoskeletons, and they're already there. They're on the market. Okay, so these are basically for disabled. Defense is a very big application of this. Okay, soldiers need to carry a lot of weight. So defense is a big user of this. Rehabilitation after stroke. I spoke about it some time back, that this is basically robots for teaching how to walk. So a person who has lost the ability to walk needs training, okay, to walk. So the person is trained on this kind of robots. This is called the basic Locomart. It is there in India also. It is in several cities they use this, although it's very expensive. Automatic transport, it is there already in so many countries. There are automatic buses which do not have drivers. They go and stop in some place, and people get up, get down. Although I doubt whether they'll work in Indian cities, but they are there around the world. Brain-computer interfaces again. This is something which is very much of interest now. One is drivers, automatic drivers. Okay, then driver tracking. A lot of car companies are already doing this. Okay, where if the driver is sleepy, or the driver is sleeping or looking at the mobile phone, it can give an alarm. Okay, so face tracking, road tracking. Okay, then rehabilitation robots, robots which are interacting with humans. Okay, now coming to education, we said that robotics has become very cheap, because of which it has proliferated right down to the school level. Now there are different robotic platforms which are available, and what I want to just give you an introduction to is, number one is that it's very, very simple. Okay, and it enhances a lot of other subjects. Okay, and it is not that it is only for technical people and for people in sciences, it is for everybody. Okay, so one of them are serial robotic platforms. The other is serial arms, robotic arms. Okay. Now, how do these robots actually work? Now, if you think a little bit, how do you drive a car? So when you drive a car, you look at the road, which is, suppose this is the road, you want to follow the line on the road, or keep to the left of the road. Basically, you look outside, you hold the steering wheel, and you turn left or right, and the car goes forward. That is how you drive a car. And basically, what we say, we call that a closed-loop control system. So a basic control system essentially consists of the driver, which is you. There is a steering in front, and there is some feedback. Where is this feedback coming from? When you're looking outside with your eyes, and then you're rotating the steering. By rotating the steering, the automobile is moving, and there is a feedback. This is my feedback, and the feedback is vision here. So you're basically looking. Okay, so this is my vision here. So we are looking with our eyes and seeing where the road is, and then tracking it. So these are four parts which are basically there, which are involved in any robotic system. Okay, so this is an example of an educational robotic system, which is a mobile robot which has sensors in front, okay, and it can perform particular tasks. So it basically consists of an actuator, basically means a DC motor, which is going to move. Then we have a sensor, which is going to send something. Okay. Then we have power, which is battery. You need to give it power. There's a controller module. Okay. So essentially, we have a DC motor, we have a battery which is giving power, we have a controller, and we can have a sensor. We need not have a sensor also, but we can have a sensor. So these four things make up the robot. So number one is a motor. Okay. Oh, I think I have it in the next slide. Yeah. So we have a motor here. Okay, so that's a motor. Then we have a controller, which is here. Okay. Then we have a battery, which is here, and some kind of sensor. So there can be a sensor somewhere here. Okay, so there is a sensor at the bottom. So controlling and adding these things, we can make a robot. Now, how easy is it to make it? I'll just this video actually explains how easy it is. So these are the different parts. You just connect the motors. Okay, to the motors we can connect the wheels. So the two motors driving the two wheels. The wheels are connected to the motors. Then there is a battery. There are sensors. In this case, there is ultrasonic sensors in the front, and there are IR, infrared sensors at the bottom to see if, for example, follow the line. This one here is a ultrasonic motor, ultrasonic sensor, and there is a controller on top. So this is the controller. So there are 4 units. You put them together, and this is your robot. Okay, it can be simpler than that, right? We can have arms also. That is a mobile robot. This is an arm. So we have the motors, these are motors. Okay. And there would be a battery somewhere inside there, and there's a controller which is inside here. Okay. So we can again make these links together, and we can make a serial arm robot now. So you can very well see how easy it is to make a mobile robot and to make a serial robot, serial arm robot. Okay, for students. These are not industrial. These are for just for teaching. But this, because first of all, the controller has become very, very cheap. So this is Arduino microcontroller. So this is a microcontroller, which is basically, technically it's an Atmega, a 16-bit or 32-bit controller processor, and it looks something like that. It costs how much? It costs 500 rupees. You can buy it on Amazon. Okay, and you can buy it on most of the electronic street shops also sell this these days. Now, if you're wondering where have you used it indirectly, most of the washing machines, microwaves, they all have controllers, and a lot of them are these Atmega controllers. So sitting everywhere in your house also, you don't know they're there. Okay, in cars, the automatic backing of cars, those sensors are ultrasonic sensors. Okay, so the sensor is there. Automatic transmission, automatic fuel injection is done by a electronic system today, which is again controlled by a microcontroller. So this is sitting in your car also. So it is there everywhere. We don't see it. Now, this is essentially the microcontroller, and this microcontroller can be used very, very simply to control a DC motor or to take sensor input output. Okay, it is so simple that you'll be surprised that it can be done so simply. Now, the microcontroller basically has pins. Okay, so these are pins of the microcontroller, and what you need to do is, depending on the pin number, so the pins are basically told in the manual that which pin does what. So the power pin basically will tell you have to give the power there. PWM pin is used for driving motors. So this is the one that is used for driving motors. So these pins. That means your DC motor, you can take it and connect it to this pin, you can connect it to that pin. Okay. Now, how do you write the program? Now, the program is so simple. Now, each of these pins have an input or they have an output. Input, as the name indicates, that if you're connecting a sensor, okay, you want some sensory input, then it's an input pin. If you're connecting that to drive a motor, then it's an output pin. You're giving a voltage out there. You're driving the motor. So they are just two functions of a pin, input or output. That's it. Now, how do you write it in terms of a program? Okay. So how we write it is basically, this is the basic command line. Okay, nothing to get scared about. So it's the pin mode, pin number, and pin mode. So this is actually the syntax for the program line. Okay, so the pin mode says you have to set the pin either to input or output. Okay, so the pin can do either an input or an output. So you have to first tell what is the pin number and what is the mode. Is it input or output? Okay, then you can do a digital read if you're reading something from a pin. Okay, so it is very logical that first you tell the pin or you tell the microcontroller that the pin is an output pin or an input pin. Second, after you have said that, if it's a read pin, that means you're reading a sensory information from the sensor, then you can read it as a read pin. It is going to read pin number. Suppose pin number was 12 here. We can write pin number 12. So it says it will read whatever signal is coming on the pin number 12 it is reading. Digital write. Now, if you're sending a voltage out, you can simply say that it's a digital write and what value. So it's 5 volts. It goes out. Okay. Pin number says 13. Okay. So just these three commands is enough. Okay. Just these three is enough to drive a robot. Okay. You'll be surprised how easy it is. Just these three is enough from a very, very simple kind of robot programming. Okay. Now there are other files which run the microcontroller itself. Now those program lines are actually available in open source, and this is the same everywhere for the microcontroller. So you just have to copy it and paste it, and then. So if you want to blink a light, for example, there is a LED, which is this one. Okay, so there's an LED is a white light. It's a red light. So it's a red light. Okay, like the Diwali lights that keep blinking. Okay, that's another example. So a very small chip which is controlling your Diwali light, which is blinking. So that's a chip. Okay, so again, something we have it in our houses. So if you want to blink this light, okay, what is the program associated with it? It's just these few lines. First of all, you set the pin mode to 13. Okay, so the pin mode for this 13. Okay, so it's an output pin because you want to send a voltage out to put on the light. So it's pin mode 13. Output is an output pin. So we are setting the, so this is the pin setup. So this is setting up the pin. Next, this is the one that is actually blinking the light. Okay, so digital write LED built in is number 13. High means it's making it 5 volts. It's giving a voltage high. Then it's giving a delay of 1000 milliseconds. Okay, which means that after giving the voltage, you wait for 1000 milliseconds. Okay, which is about 1 second. And then, sorry, it's about 10 seconds. And then you do digital write, you make it low. So first we are making it high, the light is coming on, then we make it low, which is 0 volts. Okay, the light is going off. Again, you wait for 10 seconds. Sorry, not 10, 1 second. Okay, so basically this is a very simple example which shows how easy it is to program a microcontroller. There is nothing to be scared about. Okay, there is not great technology involved that you have to learn and take courses to do this. Once you know these 3 lines, you know what it is doing, and it's so simple. Okay. This is also the reason why in schools students get involved with microcontroller programming from a very, very lower class. I think class 4, 5 kids can do this. I've seen this in many, many school kids doing this in class 4, 5 because it is so easy. And it gives you an idea, it gives the logic that, okay, I want to blink the light, it should be on for 1 second, it should go off for 1 second. So essentially this is putting it on for 1 second, putting it off for 1 second. So that logic, and then to make the connection, this is something that is what we talked about. It gives you a better feel of learning, and it gives you that logical way of thinking. Okay. Now, the fun for actually programming this, running it on your computer, and looking at the light blinking on, off, or driving a robot, that fun you can get only by doing this. Okay, you can't get this fun from any other subject. Okay, this is essentially to show that it is so simple today, and we can it can be done by school kids of class 4 and 5. Now we can drive motors. Okay, motor driving is a little bit more tricky because we have to make the signal high and low by using what we call pulse width modulation. Okay, so this again, there is a channel number. All you have to do is in that channel number, you have to control this pulse width. Okay, to control the position of the motor. Okay, or the voltage that is going to the motor. So if you want to run the motor faster, you increase the pulse width, the voltage will go up. Okay, motor will run faster. If you want to decrease the speed of the motor, you decrease the pulse width, the speed of the motor will come down. Okay, so this is again something so simple to drive a DC motor using a microcontroller. Now, let us not go into this. Now we have seen that robotics is there everywhere, movies, cars, education. Okay, and there are a lot of robotics movies, cars. Now it's very important that what are the other areas that are going to impact our lives in the near future, if not today. Number 1 is cars. There is already a lot of sensors, controllers in cars. Driverless cars are coming. They have come in several countries overseas. Okay, and some point in future in India it is going to come. So when we said you should prepare the students for future, this is what is the meaning, that if they know what is sensor, actuator, controller, okay, it is essentially these 4 elements which are connected together in whatever application you talk. Whether it's a car, it's a washing machine, there is an actuator somewhere, there is a sensor somewhere, and there is a controller somewhere. It's just a connection between these 4. So if you know sensors, actuators, controllers, it's just the question of the application. A smart home today, we say, is one in which the light can come on or the light can go off. We have street lights which come on automatically when the sunlight goes down. Okay, exactly the same. Sensors, actuators, controllers. Now, in terms of education, something very important today is that education is slowly becoming interdisciplinary. Okay, it is not possible to only say that I am specialized only in a particular area. This is true of engineering. It is true of teachers. It is true of different subjects. You should know other subjects also. Okay, so in one side we are specialized. On the other side, we are actually interdisciplinary. So that's a very funny kind of a situation. The other area where we need to look at is, if you look at the rate in which products are progressing, And this is a very interesting slide, which says that telephones took 75 to reach 10 million, 100 million customers. Okay, the telephone took 75 years. Okay, the web took 7 years to reach 1 million customers. Facebook only took 4 years. Instagram took 2 years, and Pokemon Go, that game, took only 1 month. Okay, so if you look at the speed at which products are coming, at which technology is coming, the speed is just too fast. Even for the technical people, it's just too much. So it's a good idea to be exposed to what is the basics of this. Okay, that is what we meant by preparing students for the future. Now, these are all examples which did not exist 10 years ago or 15 years ago. iPhone, iPad, Kindle, 4G. We have 5G now. We have Uber, cabs, Ola, Airbnb, Android. These were not there. These are there today. Okay? And the basics of them are the same: sensors, actuators, controllers, programming. Now, the impact of education, although this is more focused towards engineering education, number one is this excellence through interdisciplinarity. Okay. Then adaptability to rapid innovation cycles, survival in Industry 4.0. Okay. Then a new business thinking, taking risks, dealing with uncertainty, wrestling with creativity. But the question that comes up is, how do you teach all this? We know that these things are required. Students need entrepreneurship skills, technical skills, managerial skills. But how do you teach all this? How do you make a person creative? Okay, can you read a textbook and become creative? Okay, how do you teach innovation? These are questions that are being asked today, because we feel that if you want to survive in the future, okay, we need to have these skills. Okay. In terms of teaching itself, the new kind of teaching is coming. Okay, well, not coming, it has already come. I'm speaking to you over the net. Maybe last year, if this workshop was held last year, maybe I would have come there personally and spoken, but now I can't come personally. Everything is online. So we are talking to our students online. So what we call massive online courses are already there. Okay, so education is changing. We need to change. So massive online courses is already there. Now this is supposed to be the way education was. You have a face-to-face teaching, you have online distribution of material, you have exams and certificates, you have a lab experience, and then you have exam certificates you get here. This is the way exam courses were run. This is the way education was. This is the new kind of education. Face-to-face teaching is not there anymore, but face-to-face over the internet. Okay, the distribution of learning material is again over the internet. Okay, labs are over the internet. Okay, so the student is sitting at home. Exam certification is again over the internet. So this is the new kind of education we are in. So learning about programming, learning about software, sensors, actuators, controllers, robotics would actually help, because a lot of this is involved in this. Okay. Now, this is an interesting part. I think I've run out of time, so I'll just wrap this up. Regarding teaching, is that the way teaching is going, this question is becoming relevant, that can robots teach? What do you mean by that? Can we have an online lecture or an online course being conducted by a robot itself? Now, physical robots are already there. Okay, in many countries, they do not have teachers. Okay, in India also, I have been approached by a lot of companies where in village schools, they don't actually have teachers in remote villages. In village schools, it's difficult to teach English. There aren't people who can speak English properly, teachers. So can we have a robot which can actually teach? Okay, so this question is relevant even for India today. Okay, so these are robots which have been designed essentially for teaching. Okay. Sometimes languages. There are dance teachers. It can teach dance. Okay, robots just for interacting with kids in schools. Okay, so this is the next generation of teaching. Okay, and this is robots in some way. We have already social robotics. We have chatbots where you can chat with a robot online. Sometimes you cannot make out whether, say for example, in railway reservation or in airline reservation, very often the help that comes there. Okay, so when you send them a query or you contact them, you get an answer. Now, is that answer coming from a human or is coming from a machine? You can't make that out. It's difficult. Okay, so that is also a type of robot. So preparing students for the next generation would actually help. And before we train the students for the next generation, we ourselves should be familiar with what is going on. And what I basically wanted to show is that it's not very difficult. This is a study which was done, okay, in schools regarding robots for teaching. And this is some of the responses. Some of the questions are very interesting. You can, for example, the elementary school, middle school, high school, female students, male students, average age was different from 10 years to 18 years. Now, these are the questions that actually come up. What do you come up with first when you think of robots? What would be the gender of the robot? Okay, so these are questions which are relevant today. It was not relevant 10 years ago. Would it be necessary to learn about robots? What if you learn robotics in school? So what about this? Would it be possible for you to learn from robots? And if it's possible, what would you like to learn? Okay. If you look at the answers, they're interesting. In the lower kids, they said that robots are like magicians. The elder fellows said that they're like machines or tools. Okay. People felt that robots should be like human-like appearance. Okay, they should not be machine-like appearance. Then what would you like the robot to do? For example, they could be home companions or applications. And so these are some areas. For example, what should the robot be capable of doing? It should be capable of tutoring humans in general. They could be home tutors. They could learning assistive robots. Okay, they could be in areas like computer programming, maths, science, curriculum, memorizing languages, etc., etc. Okay, so this question is very, very strange. That in future we could be having robots which are teaching. Not in future, they're already there, but in a much larger scale. Okay, so would you like to learn from a robot? Okay, please think about it. Okay, so so I think I've run out of time, so I will stop here today. And if there are any questions, I will answer the questions and then we can stop. Okay, so there was a question regarding that automatic dolls. So so historically, these automatic dolls were made, I think, in Japan only, which could perform particular tasks. For example, they could draw pictures and write simple things. And in Japan, they made this tea serving doll. Okay, so it was a doll which could serve. You take the teacup and put it on the doll, and it will take it somewhere and serve the tea. But these are mechanical devices. Okay, that means if you how would you power it? There is no controller there. Okay, the year is 1780. Okay, so the year is somewhere around 1780. So where is the year? Yeah, so 1780. So there is no electronics or control there. So how is the power coming? There's no battery there. The power was basically by springs. So like the older watches, they would wind it up. Okay, and this doll could go in some places and do particular task. This is there. There is a robot museum. I don't have. Maybe you can have a look at the robot museum. Okay, robot museum in Nagoya City in Japan. It is there, and these dolls are there. They actually go and do particular tasks, but they are mechanical devices. No controllers, no programming. Okay. Any more questions?
So, am I audible?
Yeah.
So my name is Divya and I teach biology in high school. So my question to you is, I have seen how we can prepare or make our own mobile robots using the kit which is available. So
Yeah.
how I can use those type of robots to teach biology, even though there are a lot of medical applications which you have shown us today.
Yeah.
My question to you is, how can I mean, make my subject more interdisciplinary? How can I teach myself first to operate a robot, or how can I learn to do the programming, because I don't have that knowledge.
Yeah.
Even yeah.
So first of all, these robotic kits are available.
Okay.
So robotic kits like Lego is there. Then there are a lot of robotics companies which are selling these robotic kits. Now they come along with the manual and the programming help.
Okay.
And the programming help only involves writing a program in English language, and they basically have 3-4 lines only. Okay.
Okay.
So if you want to start off, first of all, you should get familiar with this robotics kits which are available.
Okay, sir. Okay. So
And yeah,
that will help me to, teach any topic or concept in biology, like
yeah. No, that will help you to understand the basics of what is a
robot.
the fundamental, the sensor actuator controller inside and the
Okay,
programming.
the
Now,
components.
the components. Now,
Yeah.
what are you going to use it for in biology? Okay,
Yeah.
so that is something that you can you'll have to think about. For example, what we do is that what I do, in fact, what I do in terms of research is also we try to see how biological systems move.
Mm.
How does an ant
Okay.
walk? How does a dog run? And based on that, can you make a dog? It's the same thing actually. How do human beings run? How do we walk? How do I pick up something and keep it someplace? So emulating insects and insect behavior is a very, very big area in robotics. So you can see how insects are performing a task. How does two ants, I don't have the video here, but it's a very interesting question. So an ant, if you see how ants carry a piece of food or something, you'll find 3, 4 ants, they carry it and they push it and take it somewhere.
Because of the hormones, yeah. The hormones,
Right?
they sense the
No,
hormones.
hormones is for tracking trajectory.
Yeah.
That's what, but I'm saying when the ants are carrying something,
Mm-hmm.
they position themselves around that object, then they push it and take it somewhere.
Exactly.
So,
Yeah.
so can you make 3 of these mobile robots, the ones I showed,
Mm-hmm.
and make them cooperate and push an object and take it somewhere like 3 ants?
Okay, so we can actually teach them different processes like these things,
Yes,
right?
yes.
Yeah.
So emulating biology in terms of animal behavior, insect behavior is a very, very big area. And you can make multiple robots do similar tasks.
Okay, kind of simulations, right?
Actual, why simulation?
Okay. Okay, got it.
So 3 robots can actually push something and take it somewhere, right?
Right, right.
So if you see how ants are doing, you first see how ants do that. Then you'll know. They position themselves accurately and then they do the task.
Okay.
So that involves learning what ants are doing. That involves some amount of mathematics, which involves where the forces are being applied. Then you're doing the programming to behave that way only.
Okay, understood. Understood.
Okay?
Thank you. Thank you, sir.
Yeah. Any more questions?
Good afternoon, sir. Do you hear me?
Yeah.
Myself, Kaushik Sen, from DPS Guwahati.
I
Sir,
can't hear. Can you speak a little loudly, please? I can't hear you.
yeah. Do you hear me, sir?
Yeah, I can hear you now.
Yeah, myself, Kaushik Sen, from DPS Guwahati.
Okay.
Okay, sir, I have 2 questions. First is regarding the social aspect of exercise of robotics. Okay. Before I've been in the teaching profession last 10 years. Before that, I used to work in a multinational company, and I saw in my company around like 50 to 60 workmen had been reduced due to the implementation of automation. Okay, ultra modern
Yeah.
robots. And there was a joblessness. Around 50 to 60 people were they were out of the job. This is one of the
Yeah.
aspects. More and more implementation of AI and as well
Yeah.
as the robots,
Yeah.
modern robots. It will the human workforce that will be eliminated. This is the first social aspect, and the second thing is regarding the paradox, like AI paradox and that singularity paradox. That's so more and more that advancement of AI, it's also fear that they may they may self-learned machines and they will learn themselves. So in that regard, what is your opinion, sir?
Yeah. So first of all, is can we escape from this? Okay, whatever your view may be, that machines are good, machines are bad. That's a different question. But can we escape from this cycle? And the answer is no. Why? Because essentially companies have to make profit. Now, if companies have to make profit, then the only way they can go forward is that human labor cost is going up. I'm talking about the world. Okay, every country in the world, the cost of labor is going up, including India. But the cost of machines is coming down because controllers, sensors, actuators are becoming so cheap today. Robots are so cheap that the cost of labor is going up, the price of robot is coming down. So if a company has to survive, they have to automate. There's no way out. So there's no question of not getting into that cycle, whatever the reason. That's one. Okay, so all countries you see, whether they are even country like India, where we have unemployment problem, companies are actually going in for automation because they have to survive. There's no way out. The second, the point is that we understand this process is coming. So we have to be prepared for this. Now, how do we prepare for this is automation and AI is taking away jobs, yes, but they're also creating other jobs. Okay, what I mean by that, majority of jobs that are coming up and in Indian, in terms of the economy, is IT related jobs. And the next generation is supposed to be AI related jobs. So if we can prepare our students for the future now, that these are the jobs that are going to come up. Some jobs are going, some jobs are coming. But what are the jobs that are coming? If you can get into that area, then you have jobs. And that is the only way we can go forward. There is no other way out now. Okay, so even advanced countries, they're basically looking, the companies are actually reskilling. They call it reskilling of workers. That the old skills are not valid anymore or may not be valid. What is the new skill set that you must have? So you have to reskill yourself. As somebody from the company, as a teacher, we have to reskill ourselves also. Okay, I can't keep teaching the same thing I was teaching 10 years ago. It's not going to work anymore. Okay, and this is a very good example that we have all gone online now. Okay, I have to think of teaching engineering, things like drawing online, which I could never do, never think about 20 years ago. Can I get away from this? No, I can't. So you can't escape this, but there are new jobs which are coming. So you have to reskill yourself at every level for the new jobs now. And we need to prepare the students, okay, for the future that is coming. And that is also the reason I started off this lecture by saying that robotics and AI is the future. You can't escape from it now. Okay?
Yes, sir. Thank you.
Any more questions, please?
Hello, sir.
Yeah.
Sir, I just wanted to ask where should we write that code?
Okay, so that is normally, okay, so I did not go very much into detail today. So so just give me a minute, I'll just scroll down to that spot. Yeah. So here, if you see, is the microcontroller which is sitting inside the robot, okay? Now the microcontroller is connected to a PC or a laptop. So you're going to, and in the PC or the laptop, there is a software which is running, which is the Arduino software which is running. Okay. So first you write the code in the laptop or the PC, and then you download it. Okay. So once you download it, then you disconnect the computer from this. It is downloaded onto this itself. Okay. So this Arduino software is open source. So you can download it free. The manuals are there. There is a user site also. So if you have any questions, you can go there and ask, and there are people who will answer you. Okay. So the code is written on the PC or the laptop, and then it is downloaded onto the microcontroller. Okay.
Okay, thank you, sir. Thank you.
Any other question?
Hello, sir.
Yeah.
Hello. Good afternoon, sir. I would like to ask, from where can I buy the Arduino toolkit? Not just the Arduino, but the entire toolkit, like the batteries and all, the motor and all those.
Okay, there are some robotics companies in India also which are selling this. So if you buy a robotic, like mobile robotic toolkit, then it will have all of this. Otherwise, you can go to Amazon. Amazon is selling this. Okay, then there are some, then there are some
Thank
other,
you so much.
okay, you can buy it online.
Yeah, thank you, sir.
Okay, so
So
let's,
good afternoon.
good
May
afternoon.
I ask, like, which one is better, Arduino or Raspberry Pi?
Raspberry Pi is a little bit more expensive, and it can do a few more things. So depending on your application and the speed of processing that you want, number of bits that you want, all that, then you can go for a higher end or lower end. So there are a lot of these microcontrollers. We have Atmega is there, then PIC is there, PIC microcontroller is there, Raspberry Pi is there, and a BeagleBoard is there. Those are more expensive and they can do more things and they are faster. Some of them can do vision processing, for example. So depending on your application, you can choose which one.
Okay, sir.
Okay, so let's stop today. Okay, thank you for your attention.
Thank you so much, sir, for such a wonderful session. Now, I would like to call Mr. Yogesh Kumar for the vote of thanks. Over to you, sir.
Okay, ma'am. Dr. Ashish Dutta, Professor Mechanical Engineering Department, IIT Kanpur. He tells us about the introduction of robotics. Robotics are very much a part of our daily life. He tells about the advantages of the robotics. In a recent time, life of an Amazon robotics, how robot works, or robot works as a machine, or you can say intelligent machines. There are various types of kits which are used in robotics and social robots. He tells us about the gender of robot, whether a robot is male or whether it is female or neutral. He tells about the artificial intelligence. He tells us about the work of robot, preparedness, teamwork, fun, or you can say learn and making. Now, origin of the robotics. A robot is in 1945, or master robotics are made in 1945. Mobile robotics developed for education and research. Thanks to all the participants and Dr. Dutta to be present here. Thank you. Thank you.
Okay, thank you.
Thank you very much.
Thank you. Yeah, thank you. Bye.
Thank you, Yogesh, sir.
Okay,
And
thank
thank you
you.
so much, Dutta, sir, for such an insightful session on this. Thank you so much, sir.
Thank you. Okay, bye.
So now we are having a 20 minutes break, and we will take a break and short break, and we will resume it at 3 o'clock. So all the participants are requested to stay here so that there is no hurdle in that, and we will start at sharp 3 o'clock. So be there and please fill the feedback form which is given in the chat box. Thank you so much.
Ma'am, can we get feedback of the first session?
Ma'am, it's already shared in the chat box and its time is going out. So no problem, ma'am. You can fill the next forms. We will. There is no issue in that, and you can attend all the sessions. It will automatically generate the attendance, and if you have attended the sessions, your attendance is automatically marked. And for feedback, if one is left, no problem. You can check all the forms which are coming in later. Right?
Thank you.
You're welcome.
Ma'am, Shama,
Yes.
I just wanted to ask, like the morning session, you said it will be shared on your YouTube channel. Similarly, this session will also be shared from YouTube channel.